You know, in the world of AI, for years, the rule has basically been simple. Bigger is better. But what if that whole idea is about to get turned on its head? Today, we're going to dig into a new model from Alibaba that's not just challenging that rule. It might just be rewriting the entire game.
And this question right here, this is really at the heart of everything happening in the AI industry. We're in this era of absolute titans, right? So the idea that a small, super efficient model could actually outperform the giants, well, the answer might just surprise you.
So to really get why this little model is making such huge waves, we first have to understand the core problem that's driving all of AI development right now. You could call it a relentless arms race for reasoning.
On one side of the coin, the goal is crystal clear. Create AI with flagship-level, almost human-like thinking. We're talking about models that can solve ridiculously complex problems. But then you flip that coin over and the price for that power is, well, it's astronomical. It needs massive supercomputers, millions upon millions of training examples, and budgets that are just out of reach for pretty much everyone except a handful of tech giants.
But what if there's another way? Well, a new contender has just stepped into the ring, and it's playing by a totally different set of rules. It's not trying to be bigger, it's designed to be smarter.
Let me introduce you to DASD-4B thinking. And this isn't just another language model. It's a specialist. It's a compact 4 billion parameter model from Alibaba's Apsara lab, and it was built from the ground up not just to spit out answers, but to actually think, to tackle that complex, long-form reasoning that's so crucial for tough subjects like math and coding.
Okay, to really appreciate what makes this model so special, you have to look at the numbers. The giants of AI, the models it's going up against, they're trained on these colossal data sets, often with way more than 2 million high-quality examples.
Now, in stark contrast, look at this. DASD-4B thinking got to where it is with just 448,000 training samples. That's not a small difference. That is a massive difference. We're talking an entire order of magnitude less data. And it proves this fundamental shift in thinking. It's not just about how much data you have, it's about the quality and the training method.
So you're probably asking, how is that even possible, right? How can a model learn so much from so little data? Well, the secret sauce is this incredibly clever and efficient training technique called aligned distillation.
Distribution aligned sequence distillation. It's a really fascinating process. The best analogy is a master pianist teaching a student. Now, instead of just making the student copy the notes to a song, the master teaches them the why, the musical theory, the technique, the artistry behind the notes. That's exactly what's happening here. The small student model isn't just memorizing final answers. It's learning the sophisticated thinking patterns from a huge teacher model.
This whole thing unfolds in 3 really carefully planned stages. First, the big teacher model generates a huge, diverse range of possible responses, everything from the safe, straightforward answers to really creative, out-of-the-box solutions. Then, a super rigorous filtering process kicks in, and it only picks the absolute best, most insightful examples. And finally, the student model goes on this 2-part learning journey. First, it masters the stable, reliable ways of thinking, and then it graduates to exploring more complex and creative ways to solve problems.
Okay, so a clever training method sounds amazing in theory, but the real question is, does it actually work in the real world? Well, the benchmarks tell an absolutely incredible story.
Just take a look at the AMY24 benchmark. This is a grueling test of advanced math reasoning. DASD-4B thinking, our little 4 billion parameter model, scores a jaw-dropping 88.5. Now that's not just a good score, it is a knockout. It absolutely crushes models from GLM and QN that are 8 times its size, and it even tops Nvidia's massive 253 billion parameter model. This is a true David and Goliath moment right here in the data.
But hey, it's not all about abstract math scores, is it? To see how it handled practical skills, they gave the model this pretty complex, creative coding prompt: build a whole interactive web page with an animated rocket, totally from scratch.
And the result was, well, it was nothing short of remarkable. Instead of just dumping a giant wall of code, the model actually showed its work. It revealed its entire thought process. It broke the problem down into smaller, manageable steps, built each piece separately, and even performed self-correction along the way to fix its own bugs. Honestly, it was like watching a skilled human developer think through a problem step by step.
So, what does all of this actually mean for the future of AI? What's the big picture here? Because this isn't just some academic breakthrough. It has profound, real-world implications for all of us. Look, this model doesn't just raise the bar, it feels like it's changing the entire game. It proves that world-class AI doesn't have to be locked away in the data centers of just a few tech giants. Its efficiency makes high-performance AI accessible. And because the recipe is open source, this isn't some one-off magic trick. It's a new playbook for others to follow. This is the democratization of advanced AI, and it's ready to run on hardware that you or I could actually own.
And that brings us right back to where we started. DASD-4B thinking makes a powerful, really compelling case for a future where the best AI isn't necessarily the biggest, but the smartest. A future where the next big leap is driven not by brute force, but by truly elegant and efficient design.